Yeah, this is the Mingau's code. So we need
That's
RE1. So this is the file.
Right.
Is that B cells? Oh no, it's not pure.
This is
No, it is.
all sampled together in one file.
Oh,
Right.
Okay, so in this case, quick look at the total seq part. No, not the total, the CiteSeq part.
Right.
Because so let's say first one.
How many samples are there?
6.
Oh,
3
so this is-
groups, a total of 6
I
months.
see. So this is all 6.
Right, so I'm going through the total seq part. Okay, so Shanruns said you just type in control,
Yes, it's a
and then
control
that
CO.
show up.
Right.
So it's kind of all over.
Uh-huh.
But then KO, but there you can see the color is different.
Yeah,
There's
Huishan,
darker.
you don't go use a Tisney, you use yeah, you change the
UMAP
last one. No,
the
no,
last one, antibody.
no, not last one. Huishan, you must be using older version somehow.
Oh, really?
Feature plot. Okay, use second one, feature plot. Right. Yeah, okay. Then XY, you change CON. Change, yeah, type CON. Yes. And the other one type of KO. Type of KO. The yes,
Yeah,
that
so
one.
let's see.
Then change it to log scale.
Okay.
So the middle, that's doubles.
But
And
why
then-
the KO doesn't look that good? So KO doesn't look like a distinct population though.
You
Or
can
did I
always
have that?
see.
Yeah, so why
You
it's
see, I
not?
cut a
Mhm.
let me see. Trying to. Okay, you see the middle part, that doubles, and
Yeah.
also you see single positive and also some double negative. Double negative, there's
Double
some not
negative,
stained.
yeah, but
So-
the KO is not a good population.
Not which that's no good to me. Why is you don't feel good? That's a
No,
lot of stuff.
here, right, so it's kind of like a line thing. It's not like this way, it's more like a box plot, but this is just lines.
What's going on? I don't even understand. What is it? What is it again? What's the
This is the total seq part to dissociate the KO from the, so KO means alpha-synuclein receptor knockout, and control is the, so IL-17 receptor positive. Not positive, but IL-17 receptor wild type B cell.
The line, which if I think that's if not this many cells, there's a lot of cells. Not that many cells, we're gonna see all individual spots. And you probably can open the individual file, not merge file. You probably can see right there.
Yeah.
So this is, I think this is the
anyway,
common.
here we just do a quick thing to show
How about
the
Yeah,
right. So for to answer Chen-Ming's question, 60. So that's the CiteSeq.
OYCC.
Yeah, this is LY6C. You see
Yeah.
this population, right?
Right,
There's
yeah.
these. Okay.
Exactly. Right.
So the CiteSeq part, that's where CD93.
CiteSeq, yeah, they all work well.
So there's some here and some. So we do need to be careful when they overlap.
You said it. Now the site, it looks like everything is positive except some are more positive.
That's right. It's not like they're negative. They are dark.
It's
Yeah.
like, okay, so in the parent,
So it's
Yeah,
not
we said-
positive, negative.
Which you look at, yeah, you use the other plot, the feature plot. Yes, you go back. Okay, you look at this file, it can give you better. Then you change to, you know, you X, Y axis, you change to the name. Yes, you change that.
Change to
Right,
what?
right.
Change to this.
Yes, you
Change
change it
to-
to APC IYC.
Mm.
One
Okay.
thing I was thinking, Ray,
Okay,
can I
great.
just say something? In flow cytometry, you know, you're saying something, and you get a positive and
see?
negative feed.
Mm.
Yeah, now you can see separate population, you know. That's
Mm.
that's what it look like in the fast plot. You see
Mm.
some double positive,
Mm.
you know, you see
Yeah, right. And then you see this one.
there's some background, there always some background. So but you can tell the
So there's, yeah,
oh right, yes.
I think the
So
line is and it's
the
not that
line
obvious, right?
the line, that's a cell number. I think that's because too many cells. If we don't have, if you look at individual, you don't see the line. I remember
Mm.
individual file.
Yeah, but for now, let's use so at least we can see they are there, right?
Clear.
So here it makes it more clear. We see the entire cell. CD, I think CD23 is gonna be it.
Yeah, CD23, 21, they work very well too. If you use the CD23, 21, you know, like a fast plot, you can see the marginal zone cell.
Yeah.
So
I haven't looked at this week yet. So that's yeah, you look at this, you see the
Not
background
a big
kind of high.
difference though. Right.
Which you look at the other way, you can tell which they're real positive negative. Okay, you change to CD23. Okay, click that, and then you change to CD21. Yes.
So kind of like this
Yes.
and
Right.
this.
Yes. So that's down top, that's marginal zone, right? And
Mm,
then the
right.
others,
So
that's
this
non-ING.
and FO, and this
Right.
is double negative. All right, so
The marginal zone are on the top, and F, and this big ball here is
FO,
naive. Yeah, FO.
right. Mm.
Sort of looks right.
Yeah, let me change to CD95.
Yeah, I wonder if there's a better way to plot it, like a contour plot, or
So it's-
CD95 doesn't work well to me. I didn't use it.
Mm.
It's already there, but I didn't use it to separate the population. Your GL7 works better. GL7.
yeah, yes, no CD95.
Well, you can, yeah, we have the antibody anyway. So yes.
what's this?
The GL7.
Yeah,
Oh,
German.
Let me try the GL7. Well, in a way, we don't need this because germinal
GL7?
center transcriptome is very distinct.
How about GL7 and FAS? You know, because FAS work. Oh, you're doing it. Okay. Is that GL7 and FAS?
Yeah, so it doesn't look like
The
that.
facts that doesn't look.
Right, it's not the same.
You open individual file gonna look better. This is too
Yeah,
many.
and I think we don't need this for germinal center because you will see it with the.
Yeah, Germinal Center. I just use
very,
GL7.
very, yeah. We can just use transcriptome, AICDA. It's right here. So those are germinal center. So yeah.
What about
Overall, I think what?
KI67? What was that? See,
Yeah, it's the same.
yeah.
Hmm.
So
Okay.
it's interesting when we look at the FO
Hmm.
marginal zone transitional. I don't see almost any gene show up. You know, different.
Or differentially expressed. Yeah.
Right, it's really clean. But when we look at the germinal center, the huge, a lot of genes show up.
Oh, that's good. All right, that will be interesting.
But
Hmm.
so because we have 3 groups, so every time we look at the germinal center, compare knockout and wild type, and then we have list of genes. And for 3 group, we see what is the common one. Then we look at common, I don't see common.
I think we need to remove those immunoglobulin genes first, because I kind of look at your list, and they got lots of the IgHV gene, those.
Right.
So I think let's remove those. Otherwise, those gonna kind of confuse the result.
And another thing kind of interesting is when I look at the CiteSeq, there's a protein level. I found it's all knockout, the protein level is kind of all
How do you
reduced.
know the protein level, Sharon?
Because you see for this experiment, so
Oh,
all
you mean
cells
the
knockout.
protein with this CiteSeq? Yeah.
Right, you look at the CiteSeq, you see at the bottom, well, you can pick up any population, then you click a button and they're gonna show you the differential expression. But you have an option whether you compare genes or you compare the antibody. So when you look at the antibody, then they show up all knockout, almost globally, the protein level kind of reduced, you know. So it's that I just Google and see IL-17 about protein translation regulation. Then it show up a paper, you know, the People Piper paper 2018 about the IL-17 receptor kind of connect to some kind of acting something, and then can regulate the translation for data.
Can you do,
But if all are reduced,
but
then
can you do something like that, the receptor, because you can never see those. Some, I forget what they were on the thing, but any like IL-17 receptor
IL-17 receptor doesn't,
or something that worked. Just try something you tried to work.
what do you
for the
mean?
gene, they're all positive for gene IL-17 receptor.
No, whatever you, but where's the list of antibodies again?
Yeah,
The
these
list,
are, yeah, I think these are the few ones. Yeah.
tell-
Oh, I got a list antibody.
Oh, that
Yeah, I
one.
think I did it. Oh, yes, here. Yeah, I have the list antibody or antibody too. It's
Right. So
Hmm.
let me see. Let me look at this a second. So if you do, oh no, okay.
Let's see, CD11C, right? That's kind of interesting.
Yeah, C11C might be.
yeah. You do this. You really you need
So
a
there's
you
a
need a
small population, and then
you need to
here that's
separate the
not.
cell population first, and then
Right.
separate the knockout and wild type first, and then separate each
Right.
sub
Yeah.
population.
So
Then
we're
you
not
can
gonna
see.
do it now. We're not gonna do it now.
Yeah,
But now we just kind of see, did this work or not? I think it
This
did work.
work.
Right.
I
Right.
confirm this
That's
work
right.
very well.
That's right. Yeah.
So CD11C, what's the purpose for here?
The purpose was
The same, because the ITGAC doesn't show up well. Let's say we do ITGAC. Oh, that's interesting, isn't it?
It worked.
Yeah, it worked.
Yeah, I see. So it works. but not too many cells. That's the issue.
That's
not too many
right.
positive cells.
That's right. I
But
think this
amazingly,
is
it does.
better. Right. That's right.
That's amazing. I guess it should.
How about a tax gene? Like type
You
1
want to say type 1?
ISG,
It
whatever.
doesn't work like, I think in the spleen, this is the one that show up. That's a lot. So this is the one that's different between wild type and interferon receptor knockout, this gene.
So how about other ISG 15?
No, they don't show up. They,
Maybe show up this time.
I don't know. There's some, but not a whole lot, right?
At least, can, more than 1,000, I guess.
More than last time, more than
1,000, more than 1,000 cells.
Yeah. All
So
right.
in my case, it's only several cells. Yeah, 1,000 cells.
Yeah, but they're here more than
Yeah, that's why I said
the more
1,000.
plasma cell.
Yeah. So this is kind of like my wild type mice, right?
Kind of like, that's right.
Kind of like that.
Right.
So that means maybe works for my cases also.
I think at least this strategy works quite well. I feel.
Why ISG 15?
Well, it could be there are other ones. ISG 20. Yeah.
Oh,
So this is a plasma. That's quite good. Right there.
So many plasmas. Really strange.
No. This
No,
one,
this
the
gene
dark
level.
one, the dark one.
This is gene level.
This is protein.
Oh, this protein.
Right. So somehow it's not like that background is completely dim. It is not, but so we need to look at the real dark one.
Okay, so.
Mm.
But in our CD, this antibody in our flow cytometry doesn't work well.
That's true. Yeah, I know. We don't know why, but.
But this is different. This is sick antibody. Different. Yeah. This.
So one lesson is so when I stain the by hash antibody, I stain a lot of cells. So based on this, finally, there are about 6 to 10% double negative. So some cells are not stained. So when you use a hash antibody, it's better not stain too many cells. So just make sure they all can be stained,
Okay.
Sure, it means that my sick antibody is not enough.
Yeah, I use too many. I added 20 million cells something, there are too many. Then relative the antibody not enough. The antibody didn't stain all cells. The antibody supposed to stain all cells, but some cells were not stained. So don't use too many cells, But the result,
you use the total spleen cells, right? So it's not, you use the total spleen cells, 50% B cells, right?
Well, yes, I use the total spleen cells. And also, it's better so not to do B cell purification in race. I found a membrane B cell loss, it's like L1, because L1 is.
For my cases, I'm not interested in plasma cells. I'm just interested in.
Just if you want to see membrane B cell, it's better not use a kit. Just do the sorting. The flow sorting actually, the all cells they are B cell for sure. CD19, the all B cell. Not there were no myeloid any type of cells.
How about IFR receptor?
Yeah, I can.
Wow.
Well, so the FO and germinal center, that's right.
Now, germinal center already in the center.
Right here.
Yeah.
And I think this is germinal center too.
Yeah.
So it's FO and germinal center.
Germinal center receptor, IFR receptor should be high.
That's right.
Yeah, should be high.
Okay.
One thing is the big ball of cells, the naive, I guess, or FO. You can see on the right-hand side, they're not very positive.
Right, that's right. So this is higher here.
Right, and maybe the other side is
Yeah, let's see. So we kind of, where's CD93?
right.
Now maybe we're using IgD.
Yeah, so this is
IgD.
this CD9. No, we're looking at transitional. So
Oh, how about IgD? I think
IgD.
What about IgD? Now, actually,
IgD should be very natural in germinal center.
Yes, there's a IgD FitC, which you
yeah, he actually does. He
IgD.
actually has
Right.
it. So we can check IgD both ways.
Yeah.
So,
This
okay.
kind of naive cells. Kind of naive cells.
Let's see.
The
CD21.
background too high. The background scale too high, right?
The background we wash twice. We didn't wash 3 times. So when you do it, it might better wash 3 times.
So marginal zone is on this end, FO transitional. So we don't know what this is. Transitional, FO, marginal zone, germinal center, plasma. We don't know what this is. Perhaps with the QC, this will be.
There are lots of doublets. There are 10% doublets.
You said apple. What is the apple?
What?
You said apple.
FO, follicular. FO, yeah, FO.
Oh, okay,
Yeah.
okay. Apple.
The word's transitional.
Here,
Right.
transitional. In a way, it's funny. Yeah, transitional. That amount that I noticed, it's closer to germinal center. So it is true. Transcriptome wise, they are closer to, right.
They're signaling and they're active. And then if they don't make it, they get parked over there to the right. Those are kind of inert. But okay, so that's IgD of the antibody. No, that's
this is CD21. So I think marginal zone here, FO, follicular B cells here, transitional B cells here, and germinal center here.
Dr. Shi, could you click to like receptor 7 again? I want to see different population expression. So
kind of more in the marginal zone end. Yeah, that's true. And then CD11C is here. So it might be true. This is really extrafollicular.
so it's a strand.
Oh, that's the DN2 then, right here.
Oh, yeah.
Yeah, there is a DN2.
DN2 is a high expression to like receptor 7. Surprised me. Should be. I expect to see high expression germinal center.
That's right here. So this is the DN2. So there's some in the germinal center as well, but that's really interesting.
No, it surprised me.
So yeah, this is really good data.
So okay, you can see here, germinal center, they also high T beta. You see, that's consistent with us.
So right. So, but it's not. This is another population here.
Yeah, this is in my cases. You see, I show that 40% germinal center cells are DN2 cells. 40%.
Let's see, CD8 gags.
What's the bottom? What's the bottom?
What's the, I don't know. I think we need to, this one, I still don't know what it is. These I don't know what they are. Anyway, so Yeah, so this somebody can spend the whole holiday working on this, right?
Yeah, I spent a lot of huge time
Okay.
already.
All right.
Huge.
Okay. Anyway, well,
So-
yeah, Sharon did a wonderful job. Yeah.
Sure. Can
You
you
know,
share
the-
share this lupus file with me? So I when I get time, I can search that some gene to see works. Yeah.
Sure.
You just put it in the share drive
Yeah.
in my antibody. Yeah.
But can you go back? I was wanting to see, that was good to look at that. IgD in both ways. You see IgD at the antibody level. What about IgD at expression level?
IgD, you mean the gene?
Yeah, the gene.
Right.
Yeah, it kind of answers the enzyme.
This is IgD also. So this is not germinal center, I guess. All right. So plasma cell, but look at this. This population is making it as well. So it's an alternative route of making antibody. It is true. It's not germinal center.
So how about Icarus?
Icarus, yeah, it should be. It doesn't.
What is that little population down there?
This one,
Yeah.
that's the DN2. It got the DN2 signature, but it's not germinal center.
Yeah, it's in
Right.
in the marginal area, I guess.
Right, that's right. Icarus, yeah, what's the name? It's not Icarus. KZ, like a ZF1.
Yeah, yes, it's this one.
Now, let me get one thing straight.
Hmm.
There's DN2, that little bleb down there.
Right here, right.
Now, there's also,
These two are germinal center.
right, also this Tibet, which we know is
Hmm.
up as a result of interfering gamma in germinal center. And there's two populations. I mean, how can there be two? Or there's more than,
Right, so.
I mean, there is that population down there. And then there's that population way down there in Australia, you know.
Here?
Yeah, that one. So, and are they, is that not, that's not non-specific, right? You know,
this is, and I think we got CD11C. Let's see, CD11C with the antibody. This is the main one. CD11C, and there's a little bit here and a little bit here, but this is dominant right here.
So this is sick antibody is much better
This
than
is
our
antibody, that's right.
So sick antibody different.
So there's CD11C positive, but Tibet.
When you look at CD11C cells compare knockout, white have there are huge amount of gene difference.
That would be quite interesting, right? I think this would be the kind of thing, yeah.
So I figure, you know, I feel as long as the, you know, the cell pass the antigen, express antigen, germinal center after that stage, on or after stage, that stage, the gene, there are a lot of difference, between. Previously, the single cell experiment, we didn't have that many GC cells. I believe that's the reason, you know. And actually, this time we still you know, lot of the FOB cell, but we still don't have that many as.
Oh, that's right, because we need, that's why it's so big, right? Yeah, because
it's a lot, but it's 700. Not, for example, I think it's still less than 1,000, but for
Yeah.
FO, it's
Right,
almost everything
still.
more than 1,000.
Right, still it's mainly this,
Can
right?
you,
So for FO, and we don't see the difference. It's almost all samples are same.
Yeah, all right.
Jim, what other DN2 things are there?
Well, it's a ZEB2, ZEB2. Because that one show up in mice. Yeah, it's the same area.
Yeah, it's a DN2.
Yeah.
But also pretty high
It's a little bit here. Right.
In the left corner also pretty high.
I think, I don't know if these are good cells or not. I think they're high in so many things. So we need to clean up the dead cell, remove those first.
Well, here's the thing. Here's what I was thinking. TLR7 is clearly marks the true DN2, right? The true DN2, which is over there, the bleb, the little South Korea bleb. But yeah, South Korea, you know, whatever. But they, yeah, TLR7, but they don't so much mark the other ones. I guess there is a little bit now that you look at it. So
right here, a little bit, right?
Yeah. So TLR7. So there is a little.
I don't know if TLR7 should upregulate in some DN2 cells. I don't think so.
Right here.
Oh, it's right there. It is.
Yeah, it is upregulated.
I'm just saying. I was just noticing that it's upregulated in the sort of conventional DN2, ZEB2 positive, IgD. Are they IgD negative and CD27?
It is not IgD negative.
Yeah, it's not IgD negative.
Oh, really? Can you look?
IgD negative. CD27 also is all over.
It's right here. CD27 is here.
Memory cells.
That's memory. Let's do the memory cell. Okay. Let's there's the CD27.
So that's CD27 antibody, right? No, or is it the gene?
Oh, unbelievable. This is the same. That's amazing.
Because Shanruns put this sick antibody, so it's purified.
No, of course it's yeah, but still amazing to see.
That wasn't the plan. The plan because it was the first plan using CD27. So we bought the antibody, but later on we changed, but we got antibody already anyway.
Yeah,
so
but
that's the reason why we use it.
That's amazing. Let's see the other memory marker.
Right.
73, yes. Yeah, that's one marker. This is not good marker, I think.
This one.
Try CD73.
Right. Let's see.
I feel that's a good marker. CD73.
But no, this did something. I mean, it sort of.
It's right here. Yeah, so it's different from.
That's different. Yeah, I feel, when I analyze, I feel that's not good marker. 73.
Not that obvious either.
73 can, can seem like it can stay more
maybe here, and but it's not so obvious.
Not sure if antibody is good enough.
As it turned out, CD27 worked the best. Let's say CD80.
CD80 is not good.
Not good either.
Well, they all have this
here and then here.
I don't know about that one, but
little bit here, right?
They all cut down through, through
this, yeah.
And then they hit that little population of CD27.
Yeah.
Some of them wander over.
Can you put the IgD again? IgD again to see it's located on the DN2. IgD.
Here.
Oh yeah, it's negative. It's negative.
Unbelievable. It's New Orleans.
So, but anyway, everything works, I guess, for this.
It is working, yeah, except the view 2273, these memories work the least. But otherwise,
for my case, I don't need this memory.
yeah. Let's see, GL7.
Now, this is IGD. The one you just said is a gene.
That's a
IGD
gene. That's
That's
gene. That's gene.
See, the gene works better than the
Oh, that's good. But here, even this area, slightly. So they're really not classical germinal center. It is not. So this Neolian is funny.
That is us, maybe.
No, it's way too specific. I just don't think it's dead cell.
But no dead cell. I don't see.
Yeah.
Dead cells. I don't think you can.
It's
Look
way
at the
too-
summary profile is very good.
Now, wait a minute. This is the GL7 antibody, right?
Yes.
Now,
Right.
can you do something like AID again? You know, what is that? Is that the same?
AICDA.
Yeah, so germinal center is high. But this area is kind of like a small non-germinal center ASC area here. It is true, but they're not germinal center.
No. And they don't have high AID either.
A little bit
I
compared
know,
to,
a little bit, but you know, they're really, that's not their.
and it's not BCL6
it's not germinal.
positive. Right. It is not germinal center, but it does have some feature to allow them to make antibody.
Can you put in a, here's a critical thing. How about IgG1?
I just did IgG2C. You could see that this area, the germinal center, they're making, I think this is higher. Of course, cannot compare with the plasma.
Oh, 2C, okay, that's 2C. Is 2C is the one that's driven by interferon gamma, right?
Right, that's right. And 2B is less so, we think. Still high here. So it is true, this area.
How about G1?
Yeah, it's all the same. So this is a non-germinal center antibody.
What about IG? How about IgN?
We have antibody for IgM too.
But yeah, what about the antibody for IgN? See if that works. There's so many.
Yeah.
It seems like it's a little stronger in that little dimple. And I see some IgM strong. Which makes sense because they're.
Well, yeah, so transitional and marginal zone are higher. So it is true.
Right, but that little thing isn't.
So this is I don't think their dead cell is way too specific for so many things.
No dead cells. Okay, no dead cells.
Right, no, definitely not, because what is supposed to be high for antibody production, it is high, right? And
this could be light zone.
It is extrafollicular germinal, extrafollicular antibody forming cell. So literature is right then. However, it's in the BXD2 mouse, that's not the main one. BXD2 mouse, maybe germinal center is still the main one.
Did you do IL-17 receptor?
Yeah. Right, it's very specific, but somehow they got it here too.
Did you do it? Did you do the other one, interferon gamma receptor?
Okay, this is interferon gamma.
No, it's 17.
The more, no, I'm comparing these two.
Oh, okay.
So I think, yeah, gamma is the highest in the memory, actually.
Down there.
This is the highest.
So yeah, can you put just I4?
I think we did it before.
I4, not a receptor. I4.
IO4, no way. IO4.
Sure, it's up. Yeah, I4, yeah. First one. Okay, got you.
Little bit here in the memory cell, little bit. Even that's surprising. I thought it's completely negative.
Maybe some T cells snuck in there.
Snuck in there.
Yeah, maybe CD3.
All right.
But no, CD27 memory T cells.
So Dr. Mons, Dr. Xu, I don't have some to report today. I haven't got the data for my cells. So this morning I just isolated my PBMC, but I guess the blood is not enough, or some centrifuge issue. So I need to ask Minter draw blood again. So otherwise he will leave soon. So I have to grab him.
Okay.
So I back to experiment. Okay.
Yeah, sure. Okay. Well, all right. So the only thing I would say is
find time for a personal meeting. So we maybe discuss.
No, we will have a short meeting today. So yeah, I could only say please keep on cutting down your mouse cages to everyone.
Yes.
Right.
The next week I will start try around. So I will ask you to see the good or not.
Okay, sure.
Yeah, I will schedule time. Yes.
Okay. All right. So yeah, thank you, Chen-Ming. So I think that would be it. David, you have anything to say?
No, I'm gonna cut a couple more mouse cages this week.
Okay. All right.
Because we're not gonna do. There's no sense in keeping the older GFPs that we've got.
No sense. Right.
Since I've got some that are just weaned, those would be better anyway, right?
That's right. Yeah. All right.
Those. It's not going to be a lot, but it's some.
All right.
So I cut out of a lot of cages on my side, but I still need to cut more.
Yes,
I combined
please.
all females together. So now I need I think I can probably cut 10 more cases again.
That's good. That'll be great. Yeah. All right. Dr. Mons has something to say.
Oh no, I was just saying there's a huge amount of things. One thing that's interesting is TLR7.
For the blood.
Oh, not it.
Yeah, he asked me whether I.
What's going on?
Chen-Ming just asked if either one of us could draw the blood. He asked Yang first, and I said not it.
Draw blood from who?
Him.
You mean so Young can draw blood?
No, I'm a long time I haven't do that, so I'm saying no.
I see.
I could probably do it. It's been a long time for me too, but I remember I was good at it in my day.
I've got the needle and the
I mean,
tube holder.
if it was a hard vein, but Chen-Ming has good veins, right, Chen-Ming?
Yeah, he's already gone.
I just back here. So okay, so
I can do it. I'm good at it. I want to get back in the swing of this anyway. I've been meaning to do this, so
I can bring you the tubes and the needle.
all right, I'll come down and do it. This will be fun. I mean, maybe it'll be fun for me. I don't know about you, Chen-Ming, but
what?
I can do it. I'm good. I'm very good.
What did you say?
Never mind. I'll do it. It'll be the greatest blood. You'll really be happy with the way I do it. David, I did David subcutaneous injections, right? David, was I good at that?
Yep, you were good at that.
Right.
He actually surprised me because one time I got this upset. It's a huge one, and Dr. Ma just came and just took it out.
Oh, I would forget about that.
Right. So he amazed me sometimes.
I'm good at these things.
Right.
But those patients over there, I mean, I poke at them all the time. I'd love them come in. Oh yeah, bursitis, we'll get that. Injecting their bursas. The only problem is injecting them. Cole knows. It was easy. I used to love to inject bursas, shoulders, hips, back, especially shoulders. They're very good. And bursas, these greater trochanteric bursas. But the thing is, it's the paperwork. I used to just yank out a syringe and draw it up and start injecting. But now you got to fill out all this paperwork and get the time out, and it's like a procedure. This isn't a procedure. I'm just injecting the bursa, I mean, I'm careful. One thing I do is make sure it's sterile. That's the only thing. You can do anything you want, but you must be sterile, right? Cole knows. Cole, don't you like injecting bursas?
I wouldn't say I like it, but yeah, I know how to do it. Yeah, but I'm not quite sure. Like even when I started to injecting something into versus, I already have to all the paperwork before that. So
Right, the
I don't
paper,
get.
right.
Yeah.
Okay.
But yeah, I'm used to it.
Well, the thing, oh, you're used to the paperwork. Okay. Well, the thing is, here's what I like about it, is the patient feels so much better because I mixed a combo of lidocaine and steroid, that like some steroid that they use. And I say, okay, bursa hurts. Okay. And I inject it and say, how's it feel now? And I say, right, that shoulder, it feels good right away. And they walk out, I see, wow, that's really good. And he said, that's been hurting for 2 years. And you just did it like cured it like that. So that's what I like about it. The patients really get instant results.
Yeah, that's right.
Anyway, what I was going to say, I was going to go back to this thing we were just talking about. I think, and I won't say too much because there's so much, but TLR7, I think TLR7.
You want me to share?
What?
Share the screen?
Okay. I'll share.
Yeah, TR7.
Yeah, TLR7.
Yeah.
So just look at that, because we're highly interested in TLR7.
Right, TR7.
So
right.
if you just look at TLR7, you see
it really starts with marginal zone and then leads to that. So this is definitely a non-germinal center route of antibody forming B cell development.
The marginal zone TLR7 should be higher. That's because the nuclear cells over there, secrete some type 1 interferon or type 2 interferon to increase.
That's right.
Right. So TLR7, and that combined. I know we have to.
Let me see if the interferon receptor IFN-AR1. IFN. Oh, it's not detected, unfortunately.
Oh.
Right. So AR2. Let's see. IFN-AR2 is detected. It's kind of all over.
It's
germinal center, memory, but then also throughout.
Can you look at like a step 1 or 2? I know that step 1.
Yeah. Step 1.
Oh, step 1, step 2, step 1.
Yeah. Just
so everybody starts still hanging on this lovely image. Step 1. It's kind of all over, not too specific, right? But a little bit. It's always these two areas. I have to say, this probably is the light zone of germinal center, and this is the DN2, STAT2. Let's see, let me see, is that really, let me see CXCR5. Let's not too specific, isn't it? Hard to know where the light zone is.
Yeah, 6L4, 6L4. Higher in light zone, right? That's strange.
So it's lower. I think this is higher. This is lower in this side. So that's should be the light zone. Okay. Let me see CD86. CD86. All right, so some CD86 here and here, and even here too.
Even where?
Here. The
Oh, yeah.
DN2, yeah. So that's interesting, right?
How about a stat 6?
Stat 6.
Oh, so it's good. The sharp.
Here, mainly. In the germinal center is this side.
Yeah, it should be even. I guess it should be even, but the phosphorylation is different.
Yes, right. The phosphorylation.
Okay.
You know, one thing.
Stat 3. Let's see. Because that's the. I think that's where the light zone, I think. Stat.
Well, maybe you can send, can you save this file just like this, you know, with all the genes here so we can play with it? And then
I will drop this into the shared drive. So
right, so when we open it up, it'll be like this.
I'm gonna save as.
Right, and drop it in the shared drive so everybody can play with it.
Yeah. So everybody can play.
I think I'm just interested in the you know, the exafolicular pathway or whatever.
Right, that's right. So well, I think we need to, let's see, today separate them.
Yeah, right.
So unfortunately, it kind of, this is cluster 6 is the one that's, so cluster 6, let's see.
Right, there you go. But to some in cluster 6 that we don't mind.
Oh, 6, yeah, 3, that's good. So that's type 2 in the barrel. And then Z2 right there. This is DN2. It is. So
I wonder why there's so many precursors or whatever they might be. Right?
What precursor? Oh, you mean this?
Yeah, why are those other ones tied into that?
Right. And there's a funny one show up out of nowhere.
Oh, maybe
right?
that's the precursor because it's just north of it and it's smaller.
I don't know, but they really got in here.
Well, I know, but can you look at what genes are there?
This one or?
Yeah, the orange little purple one. That might be a DN2 precursor.
I don't think so.
I mean, you don't expect them to be that big, a DN2 precursor set. So what's that?
That's a marginal zones. CR2 is CD21. It's only 3 genes. So it's a subset of marginal zone.
Is S1P1? You know, that's one. That's good because that's the one that interferon axon. Wait a minute. So that's the one interferon axon. And you know, we showed that. That's the one.
I think it's marginal zone with CD9. That's marginal zone.
Wait, yes, but it's marginal zone. Yes, it is marginal zone. But did the marginal zone undergo follicular translocation?
I am not sure.
It is because
down regulation of this
No, that's up, isn't it?
This is higher, so it's the gene that suppressed this. What suppressed this is the signal that really get the cell out of the marginal, out of the follicle.
Right, but it's so it's a little lower. We have to
No,
look.
it's kind of high on the high side. So
Well, maybe it's starting to get.
yeah. Anyway, I still think it's something here. Come all the way here. They all have the similar transcriptome.
Because they're all IgD negative, right? Or IgD.
No,
positive.
IgD was
Yeah.
high here. So
IgD high.
yeah, these are
mean-
IgD negative. It's only this little tip.
Okay,
Yeah,
send it. Send that to everybody. We'll look at it. I think our key question is focus on the extrafolicular. Right. We want to show that it's really simple. We want to show the extrafolicular ones by somebody's definition are really not all extrafolicular. So simple. It's just everybody's
right. This versus this, right? This versus this.
Right. What's the difference? You know, because we know
right.
Everybody gets stampeded into thinking all the autoimmune B cells and lupus are made in the extrafolicular pathway, and they're all, we knew immediately that they're wrong, and it's taken everybody, you know, the people who can't think, they just mindlessly copy each other.
No, I think pretty. Yeah, let's see.
I know. I don't think there are extrafolicular. There are not. They don't do anything.
They are in this sense. I was thinking to see any interferon signature, but I don't see it here. No type 1 interferon genes here at all.
Well, when I compare, I found that there's one came up.
Well, in the double negative too. This one?
I mean, compare knockout and wild type.
Yeah.
There was one interferon related gene came up.
Right, but here, this one, you say this is type 1 interferon regulated pathway. This is the TFH regulated pathway. I don't see any type 1 genes show up here. But the CXCR3, that's kind of like similar to type 2, so interferon gamma. But otherwise, I don't see anything. Yeah, so no type 1 gene.
Are these, Shimon, are these 3 mice together?
This is 6 mice together. 6 mice.
So there's 17. So 17.
So let's see which one has more.
Oh, Shimon. Yeah, just a second. We're still looking at this.
Okay.
I'll do it in just a second.
Okay. In Aweda on 330.
Okay, I'll be down 330. Okay.
So knockout.
What
I think they're completely merged, right?
What are we looking at here?
Yeah, they're almost 6 mice.
Yeah, so
So
hard.
each knockout, that's a 3 mice merged.
Oh, that's a knockout. Okay.
This is knockout.
Can you separate them, you know, like you do, move side by side?
Yeah, separate that. I have put it to box, but it's not finished, you know, then I shut it down.
No, but she can do it. Is the knockout and wild
No, not here. Not here. I don't see.
What, you want to separate them out?
Okay. On the other hand,
You put them side by side.
right. On the other hand,
Oh,
it's
yeah.
like
That's
number
each one, that's a
2.
2 mice per mix.
Right. So
So you
number
need a
2.
separate.
Right. So
separate.
this is mainly coming from number 2 sample. This green make the most of these. Is that right?
Yeah, it does. Yeah, 17R, the green.
But we don't know which one, right? Because this could be a wild type, could be a knockout, right?
Right.
Wait a minute. How could you say that? Can you go back?
No, because that number 2 got both group, coming from both group.
Oh, really?
Let's see, yeah,
So
I don't see-
IL-17,
Mm,
RA, well, I don't understand. So IL-17, this group 2 has both.
So I think it's from both groups. Whereas the control got lots of memory and the knockout.
Yeah, you see, I believe one phenotype is IL-17 increase memory B cells. I think for all the, I think this, I think that might be one only consistent result between all 6 mice.
Okay,
And this is a knockout.
right. This is knockout.
That you see, you get,
But the control, I see somehow this antibody staining is somewhat weaker. So there's a lot of them here too.
but antibody is weaker.
This control antibody somehow it's not as dark as the knockout. So knockout is very dark.
Yeah, why is that?
Yes, but the control, I think it's an antibody thing. It's just kind of generally weaker, except here.
Can't
So-
you separate these side by side? You know,
Well, I don't,
you can, you know, you put them like this.
Yeah, that's gonna take a while, which
yeah,
you change the UMAP to feature plot and then put the
yeah, so
put
that's
the
gonna,
control. That's
yeah,
gonna take a while.
It's a couple clicks away, isn't it?
no, not here, sample, right? So I need
Just
to,
type-
make
right.
the,
Feature plot and then put the control and knockout. Then
No, wait a minute. You had the control and knockout.
no, yeah, it doesn't do it like that.
And sometimes you get those two and you put it, you know, you.
No, that's when she does the pipeline. When she's working on the pipeline, she's separated. In this case, that wasn't separated.
Oh. So she should just separate them, right?
Then she got to redo the pipeline. That's the thing.
yeah, I feel it's better we separate, you know, so you know where you want to cut off.
So you think the
Somehow
knockout
it
is
doesn't.
high one?
This is not behaving.
No, which your software is not. Oh, your is 5.0 right now. It's a 6 version 6.
I see. It's not behaving right. I cannot really get it right. Yeah, it doesn't do it.
You're doing it too fast.
No. It's
There, you see, it does it.
all right.
Be patient.
This is
Why do you rush around?
You need to give a name, right?
We wouldn't rush around like this. Right? You're teaching everybody a bad thing.
okay.
You got to rush around, not look at your data carefully. No, we do it the right way. Oh, what's going on? Oh, I see. You're going to ignore those ones over there.
Oh, which you should go lower, a little bit lower. Those are positive for sure, you know. You see, you cut off the, yes, go down. Yes, that's it. Yeah.
Now, what's the ones in the middle? Are they just confused?
That's a doubles. That doubles dot mouse.
I see. Double. So we
That's
don't-
because we actually did a super loading, you know. So we got a lot of double, about 6 to 10% doubles.
I see.
All right, what next, Sharon?
Oh, Huishen, you did right. You should assign the knockout and the white tab in the same group. You name the white tab. You remember, you name the. So I'm thinking, how can I? Where's my cursor? I should be able to show. you know, you click, you right. You see, you have Y type knockout. You should assign each group only in one, like you know, Y type. Then in this group, you divide the cells into Y type and control. You can name, I name WT as a separation. You know, you name WT here. So I give a name in the loop file, I give a separation, then I separate all populations in this big group. You cannot separate into two different groups. Right now, you separate into WT and knockout.
Yeah.
That's two big group. You just cannot, you know, compare them together. You have to put all them together into one big group, so you can compare them later.
But they're already in one big group here. We're trying to get them into groups.
Yeah, you can. You need a regate again. You need a regate.
Well, I think let's
You need regate. Yeah, you just okay. You can gate
can I
whatever.
delete it? I can delete
no.
this, right?
Okay, you
Oh, no,
can delete.
now it's gone. No, I don't want to.
It doesn't matter because they are two different groups.
Right.
You can keep. You just need a gate population again. You go to, okay, you just gate same gate, knockout. You gate again, same gate.
I don't understand. So same
You
gate.
set up, yeah. Just draw the gating again. You know the gate. You see the blue
You
color.
mean you want to gate like this?
No, you just repeat the question. Just repeat the gating for the blue color again. You use the polygon. You know just draw this
I don't
again.
know. I don't quite understand.
Yeah. Yes. Okay, yes.
And
Click.
then
Just draw that again. I tell you. Just exactly. Yes. Okay. Yes. Go again. Yes. Go ahead. Yes. Okay. Okay. That's it. Now. Okay. Now category. Click a category. You change WT, not knockout. Change the WT because that's a group you name. Okay. And click that button and the cluster now name knockout, name KO. Okay, now save. Okay, now you see WT, this big group, you have two groups, WT and knockout.
Yeah.
You can rename WT as a, you know, another name. So you have two.
Yeah.
And
but
also
fine, right? But now how do we separate them? Now how do we separate? We're looking at
you separate them already, WT and knockout, and then each population you can gate the terminal center, you know, the other stuff again. Separate.
But we don't want to do that. We just want to see it.
Oh, you want to see individual.
Right.
You want to see the. You click the left. Yes.
Side by side, put them side by
There's a separate view. Yes, you go to Disney. No, the top one, Disney. Yes, click that one. Okay, now click the yes, click that one. Go down, scroll down. Okay, click WT. Okay, so you see one is a WT, another knockout, another unassigned. Unassigned, these are doublets or double negative. So you can gate this one, the all unassigned into a third group, into, you know, name this one.
Maybe we don't want because they're the overlapping. That's not too good. So I think really just these two, right? Because these are double negative or double
negative. You can,
so
it's better to make this unassigned, you know, just draw the gate and put a third group. You have WT, knockout, and then the third group you can name. Put a Huishen, you don't have to go.
Wait, go back to your deal.
Okay, Huishen, that's okay. Huishen, you can just stay here. Just stay here. Okay, you uncheck WT knockout. Uncheck. Right. Uncheck. Just uncheck. Yes, uncheck knockout 2. Uncheck. Yes. Okay. Now you can gate double negative, double positive. You set up a gate, and then name. Yes, you draw the gate. You draw that gate double negative. Yeah, that's when you download the yes, you gate. Yes, exactly. Yes, exactly. Yeah, you made some cells. You see. Okay.
So
now
category
WT and then doubles. I put doubles. That's exactly what I did. Doubles. Okay. Then okay, save. Okay, then there's a double negative you get against all the rest cells. You can uncheck the doublets. You can uncheck the right, so you
why
uncheck.
can't I just gate it and then just do the
You can,
same
because
thing?
there will be a few cells left over. You uncheck. Okay, now gate include all cells. No, you still have some few cells. You don't want to have any few cell, which you miss some cells. You see?
Well, that's close enough. Here, let's just see what goes.
Yeah, when you analyze, you will see some trouble. So you don't want to miss. Yes, you try to cover every. Yes, draw a big, huge. Yes, okay, and then put a WT. Then it's a double negative. Put a double negative. Now you basically divide all cells into 4 populations. So that way can save a lot of trouble for later downstream analysis. Yes. Okay.
Now go to Disney.
You can, well, right now you choose the double net. You can, yes, you can check other cells. You can just look at the WT and the knockout. And WT you want to separate again by individual sample, right?
No, not now. Right now,
Right.
we just take a quick look. That's what we want. So, all right. So now, but now we can look at the gene, right?
Yes, you look at the gene.
Right.
Yes. That's based on sample, WT knockout.
Then we can go through every one of them now.
Oh, exactly. Now we can compare.
But we don't
WT
worry about the other one. We really just worry about these 2.
Can you do CD11C?
Mm,
Now it goes
CD11C. Right, you can check
because that made it
CD11C.
very specific. CD11C.
Right.
so these 2 are what we care.
Right.
Yes. Right.
So
Yes.
we can go through this list now.
Yes, that's right. Yes,
Right.
you can check. Yes.
So this is 23. This is the LY6C.
Let's see. You're getting something good here. Okay. Just a second. Okay. LY6C. All right. Just go through the list. It'll be recorded.
Okay. CD93.
Right.
It's a lot here. CD23, we kind of know. And CD21, that's quite a lot.
Keep going. Keep going. Here's
The AID. So,
looks so similar.
yeah, it's like a mirror image.
All right. Keep going.
Okay, you can.
KI67. It's so similar.
Right.
CD11C. It's similar too. So that's the DN.
Actually, interestingly, it flipped over. It's up on top now.
Yeah. This is IGAX. I think the wild type has a little bit more. FI27. So similar. This is ISG. CD138. Similar. This is IFITM1.
Yeah, you can click the button. You can go back. You just click the button. They can tell you the differential expression gene between those 2 groups. For the entire
That's
cell.
true down at the bottom, but you can see. I mean, there are some.
Yeah, I think we just want to take a quick look.
You keep clicking.
The one we know.
What is it? IGD?
This is IGD.
Okay, keep going.
7. Tibet. This IGD gene. GG2C. Icaros. SEP2.
That's a little different.
27. 27. 73. Oh, that's kind of unique. It's here. So I wouldn't say this is not working. I think it's working. So this is DN2 then. This 273. This is the DN2 pathway of memory B cell development. This might be germinal center pathway, right?
Right. Everything's the germinal centers on top.
So 273 is not, I think both have. So in a way, this could be derived from both, but this is germinal center, this is extrafollicular. It's 80. 80 is extrafollicular way. 07, it's similar. And BCL6 is all similar. Yes, 13 is similar. QB similar. G1, GHM, IL-17 receptor, and then gamma receptor, IL-4, AR2, STAT1, CXCR5, CXCR4, CD86, STAT6, STAT3, knockout. Yeah, looks similar. So, right, so I think we need to do quite a lot of analysis. Otherwise, just like that, hard to say anything, right? Yeah, nothing really stands out very well. So.
And you look at the populations in each one, you know, like your little thing that it decides. I can see what it is. You know,
yeah, so 93 transitional is on this end. Transitional, and okay, so LY6C, that's probably plasma or memory. Memory and plasma.
Memory and plasma,
so,
I think.
Right. And this is 93. So transitional on this end. So maybe bigger in the IL-17 receptor knockout. And 23, similar. 21. So marginal zone is on this side. And FO. So in a way, this is interesting. This is between marginal zone and follicular. It could be really the MZP. So it's kind of in between. It might derive from this MZP B cell.
How about RGS13? Remember
I think we did that.
No, we didn't.
No, it's right there.
Oh.
So the germinal center is about the same. Yeah, it's about the same.
Okay. How about RGS16?
RGS16 might be harder.
No, I know, it's less specific.
Yeah, less. Not so obvious. But a little bit in the memory B cell.
Can you do your thing where it defines saw populations, color codes them?
Oh, let's don't do that now. That's another huge job.
No, it'll do it.
Hmm?
Go up.
No.
That's gonna be very time consuming.
Yeah, so let's don't do that now.
Can't it do it? Just click the right thing on Disney, go to Disney up there on top. Or gene feature expression, that's it. Gene feature expression, see that on the upper right? Just click on that. Gene feature, and then, not that, the other one. I guess gene feature expression. Maybe, okay, try that. No, not that. Not that. No, not that. Go back to where you were. Okay. No, go, yeah, there. Put them together.
Look at, can you check CD 79B?
Okay, just hold on. How do I get back to?
Right.
Okay.
Right. Check CD 79
B.
B.
Similar. Right.
Some a little bit okay. EBF1. This is a gene from the last time. EBF1.
Not a big difference.
That's from last single cell result.
Yeah, not big difference.
Not big difference.
Yeah. How about NF kappa B1? Similar too. Yeah, it's just hard to see any good difference.
I was thinking to do the genotyping to double confirm this message.
Yeah.
I check the genotype result we did. That's back to Kevin, and the genotype based on the result is no doubt. It's But when we did the experiment, we left some blood, just in case double check genotyping. So I'm thinking double confirm the genotyping again. So.
Yeah. Okay, so I think we can have the violin plot.
But you see, if we compare germinal center, GC cell gonna see a lot of gene difference.
I see. All
But
right.
it's not. It's none
Otherwise,
of them.
this is quite a similar, right? Similar. This 21 is slightly higher in the knockout. So here's the violin plot. And AID similar, but we need to zoom in there, otherwise it's kind of masked. So KI67, CD11C, it gets 7. It's actually slightly higher here. 138. Well, as if the control has more, but it's 1.5, 1.3. It's IL-4 receptor. That's kind of low, but similar. This IgD. 17 receptor does have more IgD. This is 5.5. This is, well, okay, that's about the same. All right.
Well, IgD, I mean, for some mice, for some, they have globally relative high expression for almost every gene, every protein, not a gene. Some kind of lower.
Well, so from here, it seems like the knockout has a little bit higher. So a little bit higher in the knockout than the wild type, more IgD.
Yeah, which not only if you compare that's a protein, you know, that's the reason why there are many other protein. So knockout, basically knockout, they have higher protein level for many genes, not much, just a little bit, but the p-value is very significant for all the CiteSeq protein we look at.
Right. Okay. So this is the gene. It doesn't seem like much difference.
The gene we don't see difference, but for protein we see difference.
Yeah. So the protein that seems like the 23. This is 5.3. This is 5. Yeah, it's about the same. 7.3 Q3 7. It's about the same. Maximal is 13.4. This 14.8. Yeah, this is higher even. So generally, it's about the same. CD23 is about the same. But CD21, I think the knockout is higher. So knockout skewed towards, I think that's my impression in the past too. Knockout has more marginal zone, but the wild type has more FO. So here that is true. So this is 4.5, this is 4.3. But this is quite a lot of cells, I think. So probably this one will be significant, right? This 21 definitely more higher.
Why is a double got so many things?
Yeah, this is, because it's double. It's kind of a doublet. Everything is just, I think it's a doublet. Right, that's right.
So the gene is
kind of like backs, right? When it's a double.
twice as high to begin with. Okay.
Right, that's right. Okay. So I guess this require a lot of detailed analysis. You have to zoom into the population to look at each one. That's the thing. But Shanrun already did it. So
yeah, I think that the FO transitional marginal zone, no difference.
No difference.
The germinal center, that's a focus. Germinal center and the memory. Okay. So there'll be too many, but I couldn't find the common ones. There were a few common ones, but those are, that's.
So we don't know it's really the IL-17 knockout or it's an individual difference.
So, but I'm thinking that it's very possible. I need to double check. The memory cell kind of increase, decrease for knockout, increase for the wild type. That's I need to double check because the marker, is kind of
memory. Tricky. This is CD27. I feel
the cell number, the gene. If we look at the expression, the gene expression, actually, if we compare the memory cells between two groups, we're still gonna see a lot of gene differential expressed. And also we see, I think we compare the cell number. Cell number is kind of decreased for knockout.
Right, there's definitely more in the wild type here, right?
Oh,
this is 1.4. That's 1.1 or 1.04. So there's some difference here in the.
Well, that we could actually, because every group, the cell population, every group, the wild type and the knockout, the cell number is different, and some had more for wild type, some had more for knockout. So the total number of cells, I didn't add up. But I compared each individual one. Each individual one, I have the list. Individual one, how many wild type, how many knockout, and then compare how many memory for wild type and knockout, how many GC, FO, and then compare those numbers. I don't see a consistent, conclusion. Only the memory, I think, is kind of consistent increase for the wild type. all of them. So
all right. Okay, but yeah, so anyway.
but here that's I think definitely give a hint. The membrane is more cell number in WT.
Right, that's right. And,
That's need a more
right.
comparable.
But in the 273, that's not the case. 273.
273 is not good macro analyze.
Right.
You see another issue is for this feature barcode, we did, you remember we did flow sorting. We did flow sorting. When we sorted, we use the same antibody for 27, 273, 80. You know, we use the same, and then we use CiteSeq again. So the same antibody is supposed to block, you know, block the CiteSeq antibody. And
well, so that is true. We cannot, that's right. So we cannot use these to say, because in a way it's manipulated. So I think it's
right,
the
that's
gene
not a
expression, right?
but for each group, because all the cells is stained, they were stained in the same tube. So they are still comparable, you know.
Yeah,
By
right.
same
The transcriptome, we can compare the transcriptome, but we cannot say relative cell population wise, right? So it's the transcriptome we need to compare, but not the CiteSeq antibody.
CiteSeq for each group cell, like wild type not called, they were stained in the same tube. That means that the antibody concentration is the same for both type of both population, you know. So
you know what would be good is if you work on this a bit, that you separate knockout and wild type, to separate out the populations like germinal center, you know, based on the CiteSeq.
Oh, we'll do it. We'll do it.
Then look at the gene expression, and then
yeah. But Shannon already did it. Actually.
oh, okay.
yeah, I did it.
Did
I'm gonna, you know, I think tonight when I go home, so you can, it should be downloaded. Then you can see the way I separated based on the, you know, based on
download your version, which and you save this and put it in your drive, and Shannon, you do the same, and then we'll look at it.
So you know, the way I separate, you may not like it. So you can you can check each population, see. There's an easy way to reverse. If you don't like it, you can, you know, you can reverse. Just
now, do we need to download a later version? Because she keeps saying she's got the old version or something.
I think it's better to download the latest version.
No, I think Sharon's right.
And otherwise, somehow it's just not that fast.
What's the name of the latest version?
The new version 6.0.
Yeah.
But it's not 5 for sure. 5 is June, 3 months ago. So.
All right, we'll download that. Well, okay, so we'll keep working on this. That was good, though, I think.
Yeah.
I'm gonna go. I'm gonna go so I can save. I'll put this on YouTube, I guess.
Yeah. Okay. So with